All right, so we're going to talk now about lambda functions and what they are for. Anyone feel comfortable giving me like a lambda functions in a nutshell definition?
It's a function that you do not have to create a name for, and it just kind of executes right there in line.
Like an arrow function in JavaScript. So it's just like a super simple function that you're going to be calling over and over and over.
Yeah. So I heard that it's a super simple function, kind of like an arrow function. It's a way of creating an anonymous function. Yeah, those are all pretty accurate. So lambda functions are essentially just another way of declaring a function. They are useful for creating anonymous functions similar to the arrow functions in JavaScript. So, but otherwise they do act the same way as this function does. So I do a function like, square a number that takes in a number as an argument, and I just return 2. So just returns that the square of that number. I could also write a lambda function called square number lambda, I'll call it. And I'm just going to set that equal to, and this is the way you do it, is lambda, it's the word. And then I say num, that's the name of the input, colon, and then what I want to do. So I can do square number 2 and square number lambda 2. If I run this, I should get 4 twice, except I didn't print them. Every time. There we go. So these two functions are identical. The main kind of thing to keep in mind about lambdas is that lambdas can only have one expression. So if I can't express it in one line, then the lambda function won't work. I can't do num times num is that 2, and then in another line do num plus equals 5. I could chain them together, like, with parentheses, but it has to remain as just one simple expression, which is why it's best for anonymous functions that we don't have to, that can be used for many, many things.
What do the apostrophes mean or do?
These?
Yeah.
So, one apostrophe is multiplication. 2 of them is exponential. So num to the power of 2. All right, so and with lambda functions as well, if you want to do something else, like with multiple arguments, all you have to do is lambda num1, num2, even num3, and then we can return num1 plus num2 plus num3. So you notice that lambda functions are one of the only places in Python you'll have an implicit return. We don't need to say return num1 plus num2 plus num3. It just knows that's what we're doing. Of course, if I just define my lambda function out like this, like here, without saving it to a variable or calling it in any other way, then I can't actually use it. So, yes.
Can you read lines 4 and 6 in English? Like what it's exactly doing?
Yes. So, line 4. We've created a variable called square number lambda. It equals a lambda function. Lambda here, this keyword, says what happens next is a lambda function, a one-line function. Num represents the input. So just like in our definition up here, we have our input. This represents the return value. So same as line 2 here. And now, since we saved it to a variable, if we call on the variable like this, we can call on it just like a function. So this essentially allows us to save functions to variables if we want to. So yeah, so these two, lines 1 and 2, this function and this function right here, are literally identical in every way. The difference is I can do all sorts of other things in this function. I can print something out, I could say num plus equals 3, or 3. I can make this a multi-step function. I can't do that with a lambda function. The lambda function has to be able to resolve in one expression. Does that answer your question?
Yeah.
Cool. And then line 6, this version, it takes 3 numbers as an argument instead of just 1, and returns number 1 plus number 2 plus number 3.
Why don't we need parentheses? Just because it's addition, so
Parentheses?
like around number 1, 2, and 3 to say the sum of all 3 then? Is it just because the properties of addition don't require?
Oh, yeah, we don't need to put them in parentheses. It'll just say return the return value of this expression right here. Steven, I saw your hand up.
Yes, sorry. Is there an advantage such as like memory or big O time to use lambda than just a regular function?
Good question. That's not something I know off the top of my head.
Oops.
No, that's don't say it. That shows something I'm not sure. It's one of those things that since lambda functions are functionally identical to other functions, I don't know if there's a memory advantage, but that's something I would like to look into in the future. Yeah, and because we can save lambda functions to variables, we can also pass them in as arguments to other functions. So if I comment that out and I make a function right here that says def, run function, we can take a function as an argument and also a number as an argument. I could say return function, whatever function that is, taking number as an argument. And I can then say print out, run function, and it's going to be taking square number lambda as a function, as an argument, and 6. I get 36. So the return value of this function is the return value of the lambda function with whatever argument I give it. And in this particular case, we can do that, and it's cool. It's, you might be saying, wait a second, what are the applications here, though, right? So the main application is that Python has several built-in functions that work really well with lambdas, and we're going to talk about those now. And I talked a little bit about the JavaScript equivalent of this last week, I believe, or earlier this week. No, last week. So there's a function called map. Does anyone remember what map did in JavaScript?
Return the list.
It returned the list. That's correct.
Perform an operation to each member of the array or list.
Yeah. Yeah. So it returns a list where some operation has been performed on every item in the list. So I could make, I'll say, call this map list and have it equal to 1, 2, 3, 4, 5, 6, and 7. And I want to make a function that says, I want to double everything in this list. So I could, for num in map list, and probably make a new array called double list. And say, double list dot append num times 2. And then in double list will have everything in there. So 2, 4, 6, 8, 10, 12, and 14. One of my old instructors used to call this the sandwich method, because we create an empty array, loop through it, return the array. And it works. And it's probably it is probably memory-wise most efficient, but the map function allows us to kind of do this a little more easily and elegantly. So I'm going to say double list is now going to equal map, And map takes an iterable function, an iterable object that is, and it takes a function as an argument, like we saw earlier, and it takes an iterable object. So if I want to double everything, I could make a lambda that takes num and returns num times 2. And then the other argument is going to be map list. So now if I print, I'm sorry?
I was just talking to myself.
Oh, okay. So now if I print double list, let's see what we get. So it returns a map object. So, all right, so if we want to actually see what it looks like, we actually need to convert that map object into a list. So, well, we took 3 lines to do here. Well, we took, 3 lines to do here. I'll put back in the line about double list equals. We can do in 1 line here. And it's functionally the same thing. One thing to keep in mind about map is that map will always return a list of the same size as the list you give it. So if I made the return value 3, it'll give me that many 3s. So you got to be careful about that. If you want to change just some things, don't use map. If you want to change everything, then you can use map.
A lambda is always assigned to a variable?
No, not always. I didn't assign it to a variable here. It's just passed in as an argument to map.
I guess I meant like the double list equals, so the whole thing using the lambda.
Oh.
Is that always assigned to a variable?
If you want to use something with the return value, but you don't necessarily have to. You could do just, I could do print list map here without assigning it to a variable.
Or return if it was part of another.
Yeah. So yeah, if I wanted to, if this was part of a function, I could return map then with a lambda function in a map list. Any other questions on how map works?
Are there any benefits to using this versus doing list comprehension?
Again, I think the main thing is that it is just more. It is from a amount of code perspective, it is smaller. I don't know if it's any faster or not. It does save you a lot of time, I think is the main thing. Because if I don't want to have to write out all this code if I'm just doubling everything in a list. I could do a lambda function to do that in exactly 1 line, because it's not necessarily something that's going to be very complicated. For more complex things, if you want to say, all right, I want to double things, but only things that are a variable of 2, or a multiple of 2, then map wouldn't work here, because map, using this lambda function here, we only can do that in 1 line. But actually, we could create a longer function and pass it into map if we wanted to as well. So I actually want to try this out real quick. So I do def double, takes a number, but like double evens, let's call it that. And say if num set to equals 0, return num times 2. So I can still pass in double evens here. I don't know if we need to pass in anything. I'm pretty sure it will work this way. Let's try it. But the problem with that is my double evens function. I didn't tell it what to return if it's not even. So I get none for none 8, none 12, because it'll still operate on every single item in the list. I could do else return num.
Shouldn't the last one be 14? Why did it give none after 12?
Because 7 is not an even number.
Sorry, I was looking at that was when we doubled it.
Yeah. So now I made a multi-line function if I just want to return double the even numbers. But if I want to double everything in the list, then using that lambda function with map makes it a lot simpler. So I'm actually going to keep this function there, but I'm going to return this back to the lambda version. Any other questions about how map works? Okay, there is one other function that Python has for us that can really helps with lambdas. That lambdas are very good for, that is, and that's filter. So filter is one of my favorite functions in any coding language, and if it doesn't have a filter function, I have to make one. So filter is a similar concept to map in that we're iterating over a list and returning another list. But the difference is in filter is that we want to return only things that satisfy a certain condition. So I could call this filter list. And I'll call that one, I guess we could just keep on with map list, I suppose. It's the same thing. Let's make a bigger list. Call it filter list. Let's make it a list range 1 through 50. And I'm going to make it, I'll define a lambda function, save it to a variable. I'm going to call it even divisible by 2. I didn't realize I didn't put an underscore there, or an equal sign. I'm going to say n number, and I want to say number %2 equals 0. What's the problem here? There we go. So if I want to get, I want to filter out everything that comes in here that's only evens, then I can write filter, and then I believe it'll take even divisible by 2 and filter list. Let's make sure we print this out. See what we get. So you notice with this lambda function here, instead of just returning something, I put something, essentially something that evaluates to a Boolean. It's got something that says returns true or false. So I get a filter object, which means I need to convert this to a list. So now I get only the even numbers between 1 and 50, or 1 and 49. So the idea with filter is that whatever function you pass to it, has to evaluate to either something true or false. And if you don't, it won't work, or it'll give you something you don't expect. So I forgot the equals 0 here and did just num % of 2. What do you think is going to happen? So it only gives us the odd numbers, actually. Any idea why that happened? I'm just curious. This is an interesting puzzle.
What did we just change?
So instead of doing
It gives the odd
modulo 2,
It gives
zero?
the odd indexes.
yeah, it does give the odd indexes, but why does it do it?
Equals 0?
Yeah, I took out the equals 0. Because num modulo 2 will return the remainder, right?
And so if there's a remainder, it's true. If there's not a
like
remainder.
truthy,
Yeah,
falsy,
truthy and
false.
falsy, exactly. That's where that gets you. So in this case, I said, okay, num modulo 2, if it evaluates to anything that isn't 0, it'll return truthy. But if it does, so therefore it gets added to the filter list. So that's why I have to say that. So it makes sure it says, we're checking if the modulo is equal to 0, yes or no. So got to be careful with filter. It'll get you every time if you're not careful about what your truthiness or falsiness of the return value is of the function.
Does it matter the order of the arguments?
If I did the function and then the iterable, you mean?
Yeah.
We can check. function is object is not iterable. So yeah, it does have to be the function and then the iterable. Okay, so what questions do you have about filter? In this case, I'd say like the advantage of using filter instead of, again, just iterating over the list kind of more manually is, again, it's more succinct, does the same thing. If I had to guess, I would guess that, we're talking about big O notation. I'd say the big O notation of these two kind of functions are probably almost identical. Both depend on the size of the list. And it also just feels a lot nicer to say, hey, I'm just going to write filter, do this, as opposed to for item in list, if item is this, return, add to other list. So filter and map are both great time savers. They're definitely not the only Python functions that take other functions as an argument. I believe there was another one we did a couple weeks ago. Oh yeah, it was when we were doing regex sub, for example. Can also take a lambda function as an argument. So just in general, lambdas do the same thing as regular functions. Anytime you would use the lambda, you could write a regular function. It's just all a matter of, do I feel like devoting more than one line to this or not? Same thing with map and filter. Anything they do, you can also do. It's just a matter of, do I feel like devoting more than one line to this or not? All right, any other questions on lambdas, filter, or map? Okay. All right, so in that case, I'm going to stop the recording. That didn't work. Nope, okay, I just gotta do it by hand.